Hello again, this is Noah Housley, working on Chem 105 study time. This is problem set number 5. So for me to easier understand how light moves, I drew this Chick-fil-A sauce packet, and this packet is full of energy, and it's traveling in a wave, and the frequency and wavelength of the wave is dependent on the energy. And so light moves in these packets, and Planck was the one that said that they move. Really, Einstein said that they weren't moving packets because Planck said that they are in steps of energy, and he came up with this constant that's denoted by h. So, how much sauce in this packet, how much energy, I guess you could say, is h times frequency, or Planck's constant times frequency. And how fast it goes at the speed of light. And how do we find the wavelengths? The speed of light. And then there's the wavelength here. Here's the frequency. So you just divide by the frequency. Notice that there's common variable in both. So these can be substituted into each other. You can use wavelength or frequency to find the other one. So notice that this is a constant. So if we have one, we can find the other. What this chapter, I think, is kind of saying, and also future chapters, is that I think you just need to master knowing how to work with the equations. Master the units that are in them, the numbers, the sig figs, the what can be substituted into what. Work on that. I would say download the equation sheet and master it. So what I mean is I'll show you. In number 10, the last problem, probably one of the more difficult problems on this assignment. It was asking it had a milk pail, and it was asking how much energy, or what is the wavelength, to get an electron to come off of the metal. And why this is important to know is because this is how we get solar energy. So it's asking, is there a way we can get energy from zinc? And how much, what intensity and frequency of lights do we need to point at it to do that? Okay, so first, what they give us, is what is the longest wavelength, so that's what we're looking for, of light in nanometers, note that can eject electrons from zinc metal. It also notes that the kinetic energy is close to 0. Why it tells us that, I'll show you in a second. And then it gives us that this is the work function. I'm going to call this the eye of Sauron variable, is equal to this, but what's this? And then they tell you 1 electron volt equals that many joules. Oh, okay, joules I know in energy. So first you multiply that by that. So 4.3 times 1.602 times 10 to the negative 19th. And this is going to give me joules. So I plug that into the calculator real quick. It gives me about 6.9 times 10 to the negative 19th joules. Okay, so that's how much energy it takes to get an electron off of zinc. That's what we know. That's what this eye of Sauron thing means. So we have this eye of Sauron, and we want wavelength. So then we go to our equation sheet. We say, is there an equation with both these two in it? So let's go to my equation sheet that is poorly printed out into the energy section. And we look, okay, well, there's an eye of Sauron there, but there's not a thing there. Okay, let's see if it's anywhere else. Oh boy, it's not there. So what do? Well, then we look for common things in these equations. We say, okay, there's a frequency here, a nu, not to be confused with V, a nu, and then we have that's not what we're looking for because that is V. What about here? We have C equals lambda V, or lambda nu, and we have a nu there. Well, maybe we can just substitute this in, which is what we do. Which, when you substitute, comes out to be that the eye of Sauron is equal to hc over lambda, and then we still minus the kinetic energy. But remember from the problem, it said that kinetic energy is close to 0. So since that we just treat that as 0, we are left with this equation, which means that the wavelength, lambda, what we're looking for, is equal to these two constants divided by the eye of Sauron, which is what we have. So we plug this in. Planck's constant, 6.626. I'm just going to stop there, times 10 to the negative 34.